I would like to welcome all of you to another Orbit Lab online event. And this time it's with one of the world's leading experts on artificial intelligence, Christian Guttmann. So before we get to meet our speaker, I have a little bit of info to start us off. So first of all, I'd like to tell you that this talk is being recorded. However, please hang tight, as of course, it's always more fun live. So this is what we have ahead of us today. We haven't scheduled any breaks, so when you need to stretch your legs or visit the restrooms, please make sure that your microphones are muted. And for the exercise part of the program, I'm going to hopefully divide you into some breakout rooms. And you should all go into this document listed here on the bottom. Of course, I'll also share the link in the chat afterwards. But this is a document for you where you can make some notes. And a brief presentation of the Orbit Lab team here today. We have Kasper, who is the Orbit Lab commander and also a professor here at the Department of Electrical and Computer Engineering. And you will get to meet him just in a sec. And my name is Lida, and I'm the community manager of Orbit Lab. And of course, we have our speaker, whom Kasper will present in a minute. And it would also be nice if you would present yourselves to us and to each other in the chat. And if you would write who you are and where you're watching from. And to those of you who are not familiar with Orbit Lab, I can tell you that we're a tech and innovation hub and an open community for anyone with an interest in digital technologies and entrepreneurship. And we're part of the Department of Electrical and Computer Engineering. And if you want to know more about Orbit Lab, you're of course welcome to reach out. So regarding questions, you're welcome to write them in the chat as they pop up along the way, and we'll pick them up at the end at the Q&A session. And a very quick advertising spot for an event that we have coming up at the end of June. Hopefully when the students among you are done with the exams, we're inviting you all inside the walls of our department to present to you what's going on with regards to digital research and innovation. And of course, these are our social channels, and keep an eye out for more events coming up. Of course, we encourage you to follow us and to engage with our content. So that's it for me. I'll now hand you over to Kasper so he can present our speaker. Over to you, Kasper.
Thank you, Lida. And yeah, I wish can you put the slide with Christian back on so we can see his handsome face. So I'm very pleased to present Christian Guttmann, who is I've been lucky to know for many years. We actually met decades ago in Australia, where he attempted to teach me how to surf while we were doing our PhDs. And it's been a pleasure watching his career in academia and in industry, and with this continuous focus on AI and artificial intelligence and machine learning. And back to the days where AI meant multi-agent systems and not deep learning and stuff like that. So I'm very I'm very excited to hear what's the state of the art, and I think I'll just let Chris tell a bit more about his current situation, because it's hard to keep up with his profile as he's constantly busy doing a lot of exciting stuff. So Christian, the floor is yours.
Hey, super! Thanks so much, Kasper. It's my pleasure to be here. Wish it would be in person, of course, too. I have been to Aarhus a couple of times. I really like this place, so it would have been really nice to be there. But it's my great pleasure to be here. And as Kasper mentioned already, we have a background. We did research. We sort of did parallel research in the past, and AI is something that always followed my career. So now I will be talking a bit more about AI and how it's going to be applied in healthcare. And before I dive straight in, I was still taking the liberty to perhaps say a couple of more things about what I have been doing. You see here a picture of robots that played soccer with each other. That's probably was one of my first real bigger engagements with AI, where I did research and did my some of my thesis around this area. But really, I started off doing psychology actually, and also then AI, artificial intelligence. These two areas are actually quite connected because you want to build intelligent machines, and so it's quite beneficial to know how humans work, let's say, how they think, how they make decisions, and so on. I've started companies. I'm now the executive director of the Nordic Artificial Intelligence Institute, which is actually a global institute connecting seniors in the field in order to support and guide and advise leaders in politics and industry as to how to use artificial intelligence and all its subgroups. So I have been working for large corporations, now for Tier 2 Every, Nordic AI Institute, IBM, many of the biggies, then also started startups, and I'm also active in the scientific world. So I'm at the Karolinska Institute here in Stockholm, and it's an area which is just truly exciting. I'm deeply excited about how AI is really coming to an area where it is both becoming wider and wider and deeper from a scientific perspective, but also how it's actually used and utilized in industry now. It becomes where it really makes a difference. So this talk, briefly, we have about 20 minutes in the first session together. What I often do is just ground the topic of artificial intelligence, because it is still, let's say, it is worth just rounding out what AI actually is, and then also briefly mentioning how it is used in as an overview. Then I will talk about 3 examples as to how AI will make us healthier, application examples, and 2 quick examples of some myth that exist in the area and some reality checks. And then we go into a small exercise together. As already mentioned, we will be sort of splitting the groups, and I will be very, very interested to hear what you are thinking about how AI can make us healthier, and also what the approach would be. But I will go towards the end of this talk into some more details. So what is AI? How is it used? And what's the big deal? The next couple of slides will be about that. Starting off with something I mentioned already before. One big school of thought in artificial intelligence is very much to look at how we are operating here on the left side of the screen, how we make decisions, how we are thinking, how we are creating plans, and so on and so on. And of course, also how we are, let's say, moving things, how we're behaving, and so on. So there has been a lot of focus in the area of AI on how human intelligence or animal intelligence works. And then the whole ambition is to sort of translate this into machines, into algorithms, into computational models, and see what we can actually build, which corresponds to some of those behaviors which we would call intelligent. And it's worth noting here that one way to describe AI is essentially the behavior and the decisions that would usually require human cognitive, emotional abilities, essentially. And when you look at how the human body works, I look at it often as organic algorithms, organic models that we inhibit when we have new observations about the world, and what we make of those observations and turn them into computational models. So that's really one way to look at this area from a high level perspective. When it is broken down, or when you look at the area that has been established for almost 70 years now, starting in the 60s by a group of scientists in the US. It was notably mentioned that John McCarthy said, well, AI is the science and engineering of making intelligent machines. And then really it has developed into roughly 25 subdisciplines. Some of them you see here in the bottom, some of the AI keywords that exist here are described briefly. The ones that have a red frame around them is often referred to as one of the core disciplines, one of the 25 core disciplines in AI. So you have here things like robotics. I mentioned it before. You have planning. So when you have machines that plan certain activities forward and make sequential decisions. And of course, multi-agent systems, as Caspar mentioned before, that's really when you have several independent AIs, autonomous systems making decisions. And the hot area these days lies often in machine learning. So when you have a lot of data and you need to start seeing patterns in this data, everything from your face recognition on your Apple phone or Samsung to finding abnormalities in MRIs and so on. So due to many changes in the system, or due to many developments over the last 5 to 10 years, AI has become increasingly feasible to apply in many different industries. And that has to do with increased computation, with better advances in AI, and also with much more data availability, which is one of the areas that benefits the most from it. So let's see, here's just a very quick overview to give you a taste of how AI is used in healthcare. So here you see 6 areas that I've chosen briefly from the top left, where you have robotics, perception, then natural language processing. And on the bottom, learning, multi-agent system, and reasoning. And I will just briefly mention here in robotics that you have, for example, these robotic nurses that are applied in Japanese and in Californian hospitals, which are actually guiding patients from one room to another. So these are literally robots that take a patient, often elderly, from one room to another, to a pathology unit, for example. And this just saves a lot of time for nurses, which are such a precious resource in the ecosystem. And I will expand a bit more. There's a perception part, which is related to machine learning, but here it has a lot to do with seeing certain patterns, such as abnormalities, cancers, tumors, and MRIs and X-rays, just one application area. Natural language processing is when you have chatbots, with whom you chat. Today, they are very, very, very simple implementations of these chatbots in the healthcare system. Introduce many of them, give you just a few choices, but the full power will be unleashed over the coming years with extra tools like GPT-3. Some of you might be familiar with it. They will certainly boost the type of natural language interaction with people. And so on the bottom, I won't be able to go through them here, but of course, learning is a huge area in AI when a system is able to make more sense and become better in recognizing patterns and clustering information. So that's a quick idea. I wanted to mention this particular technology, which I think has brought a lot of attention to the field of AI. It is called deep learning. And so in deep learning, you have a multi-layer neural network, which is loosely modeled and loosely inspired by how our brain is structured. We have many different neurons. The axons are connected to the dendrites in your brain. We have billions of them. And that's essentially extremely powerful technology that we have developed. And that has been existing for almost 50 years, a very long time. But it has matured. And as I mentioned before, due to computation and data, these systems are now able to become very powerful, much quicker than we humans are able to identify certain parts in the ecosystem and make sense of patterns than it was possible before. But that's a very powerful technology that got a lot of attention. And then for the introduction part here, I just wanted to also highlight, well, why such a big deal? Why are suddenly industry and ecosystems and countries and so on so excited about it? Well, because AI is considered and classified as being the most disruptive class of technologies by far. So there's many organizations such as Gartner and McKinsey and PwC and many others that consider this technology being a highly disruptive, highly impactful class of technologies. And it will be such that organizations and companies will be able to solve problems with AI that no one has ever encountered previously. So a very powerful technology, everything from self-driving cars to diagnosis and treatment of patients. Then, of course, for companies, it is important to note, and maybe for startup founders, we might have some in the audience here too, or researchers and students that want to get into this field. It is it's considered to be a massive market increase in the coming years. Until by 2030, it's estimated to be the major contributor to the global economy with up to $15.7 trillion. It's such an abstract number, but it's a big number. So, and here in the Nordics, we certainly have a lot to gain. It's estimated to be 10-20% of the GDP, which is huge. So that's a quick introduction. Now let us look a little bit deeper into a couple of examples, and hopefully they inspire you a little bit and give you more breadth as to how AI works. And one example that has become a bit of my favorite example in terms of demonstrating the power of this technology is really to using it where you have a lot of data, where you need to start making sense of data, and then comparing it also with how it's done today. And I start here with essentially using radiology as an example. So this is an illustration of where you have today and in the past. This is sort of the process whereby you have one or two radiologists looking at an MRI and X-ray. This is, of course, a simplified picture, but they will be looking at many different X-rays and then determine whether in those X-rays there are abnormalities. So is there, for example, a malignant tumor or not? So this is sort of the situation today. There is a trend towards having more and more data. There's a trend towards having detections of abnormalities in data needing to be quicker and quicker and faster, and of higher and higher accuracy. So with the system that we have today, it just takes longer. It is potentially not as accurate, and therefore this is an area where you have just an excellent application domain of increased data, where you can use machine learning, where you can use these neural networks to understand and detect if something is actually wrong. So, and in fact, this is not just a concept. This has been shown in many publications now, and it's still ongoing, of course, but in many publications, many scientific publications, whereby you could demonstrate that an AI is often much better than a human radiologist in detecting abnormalities such as cancers or other things in these X-rays or MRIs. And and of course, there is also a tendency towards highlighting that the best way forward in those scenarios is often not to have not an AI alone do these types of detections or human alone, but often these combined human machine, human AI teams are very good because each of them detect slightly different things. But what the great benefit is of such a technology is when it works and when you have properly proven for it to work in a particular hospital, for example, that you can scale it very quickly. You can scale this type of technology across many hospitals in Denmark, in the Nordics, in Europe, because it is essentially digital technology. And also all these systems are learning. So if new observations come in and it becomes better, it's technically possible to update all models in many different countries. So that's one example. Always happy to elaborate here. The second example I would like to highlight is actually quite a fascinating discovery in many ways. And in short, this is a bit of a complicated picture, but I will put it in words. Last year, it is the first time that a deep learning approach, so a machine learning approach in AI, actually discovered a new antibiotic. And it did so by comparing it and analyzing through the neural networks 107 million molecules. So these were pathogens that were in a big training set. The models essentially learned from about 3,000 different types of existing inhibitors on E. coli, for example, what the impact was. And based on that, it was comparing it to another existing database on chemical molecules and how likely it would be for them to be having antibiotic properties. And it turns out that helicine, essentially the first AI-discovered broadband antibiotic, was discovered through this process. And not only is it a very new one, which is promising to be very effective, but it has two other interesting features. One is that it is acting on bacteria and on pathogens in a very, very different way than any previous antibiotic, whereby, without going detailed, but essentially it just has a different mechanism as to how cells are killed and how, for example, iron is transported within the cell. So that's one property. And the other one is that it is also broadband. It was first just focusing on E. coli as a bacteria, but it turned out that it is very effective for already resistant sort of bacteria. So it is a mechanism that is particularly powerful in defending already known resistant strains of pathogens. And so that's a very, very powerful thing, because by, I think it was by 2050, there is a great risk that we might have very little tools left in medicine to fight bacteria, because there's so much resistance built up in the ecosystem. So that's a very fascinating research that's going on here. It will also influence many other areas of discovery, drug discovery, vaccine discovery, and there's a lot of let's say focus on this as a very powerful mechanism of finding good solutions in this space. I would also like to highlight another one, which I find very fascinating, very powerful. Which is on helping ALS patients, patients that have a motor neuron disease. It is a condition which Hawkins had. Some of you might remember him sitting in a chair and essentially not being able to move. And regrettably, one of the things that also happens to ALS patients is that they're losing their voice. And the voice is just such an important identifier of who you are. It is truly sad to see those patients losing their voice. And this AI machine learning tool and has been used in order to allow these patients to regain their natural voice. So rather than having a very robotic voice, what has happened is that many little pieces of recordings of those patients have been collected and were fed to a machine learning tool. And so it was then able to present or to how to say, the patient could talk in his own voice again, or her own voice. In this particular case, it was a him. And there is also videos and that I'm happy to share. But I think if you type it into YouTube and you look ALS and how someone regains their voice with machine learning, you find an example. So essentially, you can regain and recreate a person's natural voice. So very, very powerful and very, very important for those types of patients. So these are just three very quick examples. There are so many, there are hundreds and thousands of examples where you can apply AI. I also wanted to briefly, I think we have the time, 2-3 minutes before we go into the individual rooms, to just give you like a little hint as to what else is, what other thoughts might be very useful to have in the back of your mind when you're approaching this topic. So the first one is, often I hear, well, AI requires huge amounts of data, right? If you do not have data, you can't do AI, you can't do machine learning. And that's actually, that's not quite true. I mean, you can, there is a lot of AI that does not require a lot of legacy data. So meaning data that has been collected possibly over decades. There is a lot of technology that can collect, first of all, there are lots of methods that do not require a lot of data, such as the tools that have been used for AlphaGo Zero. Maybe some of you know this approach. It's essentially a big breakthrough whereby DeepMind developed a solution where the AI played against itself and created its own data, its own sort of world in which it succeeded. And the cool thing was that essentially it was able to play so well by its own created sort of, let's say, world of gaming, that it was better playing against the AlphaGo, which was learning all the games of humans playing Go with each other. So it's a very, very powerful technology. And there is a lot of different ways of doing it. The second thing is, particularly in the healthcare system, there's a lot of focus on the data that has been collected over decades. Everything that you might have in journal data or MRIs and so on, and they can be powerful, but they are certainly not the only source of data. So you can use other data sources such as wearable devices and other information that can provide you with much more information. So it's a bit the question, where is this data coming from and how useful can it be? That's just the point I would like to make here. And of course, also with natural language processing is actually a very similar situation. You don't necessarily need to have a huge amount of data. Second thing is, there is this idea that AI replaces doctors. And so my take on this is that, at least for the foreseeable future, it will be really doctors, medical researchers, and healthcare professionals, HCPs, that do not use AI will be replaced by those that do. I think there's truth in this statement. It will not be so much that the doctors will be replaced entirely or radiologists will be replaced entirely in one go. I think there is a lot of training, a lot of broad knowledge that's required by doctors. And I see that this combination between an AI and a medical human doctor and a team of those two will be the best way forward. Then I would like to highlight, okay, so what else is important in this ecosystem? I see now a lot, and this will be totally important, just as it is in the healthcare system today, and maybe some of you that are in the medical field and work in the medical field appreciate this. The best hospitals in the world are managed by doctors, and not by pure, let's say, experts in business and running a business, an MBA or so. But rather a typical hospital, if you look in Aarhus, if you look in Copenhagen, in Sweden or around the world, those folks are medical practicing doctors. And they do have, of course, a business acumen. There would be some, being a medical doctor certainly doesn't mean that you can run a hospital well, but it is sort of a requirement because it comes in with much more credibility. You can build effective environments and sort of know who the best are and handle also these new ever-changing new solutions that come into the field. And one very important thing now is, and that's why I'm giving also lectures and provide input, is in achieving the same within the field of AI. It's very, very important that this ever-changing field requires PhD, requires deep training if you want to build and head say everything from a startup to big organization, that you actually do have that knowledge, you have a hands-on knowledge, and you have a good business acumen. So this is something I have also given a couple of talks on that. If you look at Rise of AI and on YouTube, my name, you will find a couple of very interesting presentations there too. At least I think they are interesting. Okay, and then a last one. Maybe some of you know the Europe and the EU Commission has just proposed a new regulation around AI. And I'm seeing this could be the world, not the WOD, of artificial intelligence. And so that regulation actually shapes very much the way how we will be using AI, because it can have a very profound impact on many topics, such as self-driving cars, applying for visa, job matching in the employment office. There's so many different topics. And so the EU a couple of years ago woke up to this fact. I've been traveling down to Brussels many times. I speak a lot to ministers and also the political sphere, as well as industry leaders. But now there is essentially a very big topic, and we have to be very careful, in my view, that we do not over-regulate this. I think regulation is important, but it needs to foster innovation. And it needs to foster all this creative energy that we have in Europe. Okay, hey, this was my 20-ish minutes quick presentation. And maybe I can just introduce the two topics before we jump to the doc file that was already mentioned before. But what I would like you to do, please think about all these new opportunities that you are seeing now in this field. Where can it be used? Do you have ideas where it can be used? And when it is used, and that's the second point, what would you consider, what is sort of the important parts? What are potential bottlenecks? Whom would you need to have on board? Are there collaborations required? But share your ideas in this field. So I would be very curious to understand. And we together, Litte, Kaspar, we can then also reason around it. Share your views. And then Litte, maybe you also want to say a few words, but otherwise I would suggest we meet each other in about 10 minutes.
Yes, let me just see if I can succeed in creating breakout rooms. So you should all automatically be assigned to a breakout room in a minute. So let's see.
And I think also we encourage people to write general questions to Christian's presentation in the chat, and we will pick up on that in the Q&A session after we talk about the exercises from the breakout rooms. Is that correct?
Mm.
Yes. So I guess if people are still maybe typing up some of their ideas, if there was a couple of questions in the meantime, we could take those just to round off the exercise.
And I can also briefly mention there were a couple of good points made in the people. I was in the room too, so I was there with Sepp,
so was I.
Sepp, Emmer, and was it Hendrik now? Or sorry, you can Hendrik. Yes, I think it was. But yeah, we discussed a whole bunch of things around, for example, data accessibility. Where can you create? What type of data can you use? Emma was working partly in the healthcare system too, so there's a whole bunch of questions. Well, how can you overcome questions around regulation and so on? So all super valid points, and it goes back in. Now I'm at a point where I'm discussing a lot with political leaders and with the EU that when a regulation is created, which I think we probably need one. Let's put it this way. But it needs to be also one that continues. It allows innovation. It allows investment. It allows creative people to really utilize it. Because if we are creating an environment which makes it even more difficult to build new technologies, then of course what naturally will happen is that other parts of the world will develop then, and we will become natural importers of that technology. So just a point. But I think we are on this way. There is companies that anonymize data, for example. There's a lot of devices, wearable devices like Oura rings and so on, which is a finished product, which collects data and allows, for example, the detection of elderly patients to fall well before they fall, for example. And these types of technologies can be extremely useful in elderly care and so on. So very good points that were brought up.
So we do have a question in the chat also. I think it's a little bit of a cheeky comment from Matthias. He says, plot twist, we're all AIs. So we also have a question from Jacob. Yes. He's saying, what do you think about people not quite understanding the possibilities? I sometimes encounter people getting scared when you say it has a 98% accuracy. And then by default, they try to do manual handling instead, since humans apparently cannot make errors.
So let me see if I understand this. People get scared if there's 98% accuracy, and then they default in doing it manually. But why? What I don't quite understand is it because they think 98 is too high, or I mean, okay, so okay. I mean, there's a couple of things here. Where to start? I mean, AI makes errors, right? And that's the big difference. I guess they're scared of the 2% errors. Okay, so they may not use it because there's 2%. Well, I mean, there is sort of the general idea that the rule of thumb is that when you're using AI, there's often the question, well, when would you use it? When is it sort of good enough? And one rule of thumb is that if it is better in detecting error, detecting abnormalities, or doing something better than the averages of the best experts in the field, then maybe it is a situation where you can consider using an AI in this situation. So when it comes to diagnosis or detecting abnormalities in MRIs or doing anything else in the healthcare system, if you start having a well-performing AI, which is on par with that of human experts, I do think then that it sort of makes sense to consider it at least. And as I mentioned before, a real approach, or like let's say an accepted approach, and there's also a lot of literature and experiments being done, is really when you have an AI that, let's say, sees abnormalities, and a doctor, a radiologist, an expert. You can't see my hands now, my camera is still small, but you have these two. And when they combine, because the AI will detect and see what is missing, but in different ways, and it will see things that are missing that a human doctor wouldn't do. So that is indeed a very, this allows you to go from, let's say, an 80% accuracy to maybe of an AI versus a 75% accuracy with a human. But if you put them both together, you might achieve 85% accuracy, right? And then, of course, accuracy is not the only measure when it comes to this, because you can have very high accuracies on something that's actually also wrong. So, but that would go a little bit deeper into how machine learning also works. But
Great. There is a question, but I think maybe we should save the questions for later and move on in the program. But there's also a comment from Casper. I don't know, would that that's relating to the discussion they had in the breakout room. So I don't know if how you want to run that, Christian.
Let's see. So first, I might just put my main camera on, if that works. That's of course a little experimental here. Maybe it does work. Yes, it does. Awesome. Yeah. Fantastic. Yes. So I would say we just share. I can share my screen, and we can go to the some of these topics here that you brought up. If you like, we can do it together. There's a whole bunch of very interesting things. Wow. Okay. Yes, of course. Identify breast cancer and MRIs. Excellent. And indeed, it's done. There were studies done, just published 2-3 months ago, both for colon cancer, which is the main cancer in men, and then also breast cancer. And so it becomes very sophisticated. It is something I shared on LinkedIn recently, whereby Australia is using that. And I was pointing out that in Europe, we are having a danger of not being able to use it due to the new regulation that comes in. Developing AI team.
Sorry to develop, but maybe you can go into presentation mode so it's a little bit bigger.
Okay.
It's on top right. Yeah, there you go. Thank you.
Okay. Is this better though? I'm not sure.
A little bit.
Yeah, you can see enough if you put it probably on main screen. Yeah, develop AI teams models to coordinate patients. Perfect. I know this. What am I talking? These are actually the topics that I put in. So maybe I should jump to the ones that you put in here. So anything that allows warm hands to take care of patients. Exactly. This is often the part where in AI and human teams or doctor teams, there's often the idea that, well, the one thing that will not go away is this warm hug by the doctor, let's say, in those circumstances. On the other hand, I've also heard arguments where they say, look, if you do have a particular issue, health issue, many patients would also be happy to just have it solved without necessarily having the human there. So I think what will happen is many applications will come and fall onto somewhere on that spectrum. So hearing aid, AI is utilized to omit the other sounds by using the eye attention of other people are passing. Okay, that's cool. So you're essentially using eye coordination and you start applying it so that it can sort of channel this sort of hearing. Creating personalized medicine combinations, excellent. I mean, this is often referred to as, by the way, can you also see my cursor?
Yes, we can.
Yeah, okay, great. So creating personalized medicine, this is often called then precision healthcare or precision medicine, personalized healthcare. It's a big area where you really look at a combination of treatments and medicine, going into the direction of creating individual medication that actually suits you. So rather than one fits all, it's like one fits one approach. So it's happening. Happy to share more links. Detecting unhealthy habits from pervasive systems such as phone, wearable, perhaps prompting CBT to come back on track. This is actually an idea which was similar to my last startup called Healthy Habits, where we are developed a similar thing, looking at a system that detects and captures healthy behaviors and how they would be relevant to you. There is a couple of companies out there that are doing something like this. For example, Sidekick Health from Iceland, and a couple also in the Valley. Excellent topic. Decision support for critical operations. Not completely sure. Just looking at some others. How could we do this? Is anyone wanting to comment so far on what they have written or what they think is particularly interesting, or which they may be working on, or which they would like to work on?
What about Casper's group?
Yeah.
Well, we were talking about something a bit different, and that was a question about how do you put teams together who will develop effective models over time. And one of the frustrations was that I was in a group with a biomedical engineer and an engineer who they were working in different domains, one in trying to get into AI in healthcare and one working in a different domain. And they were a bit unsure if companies were more looking for people who could implement more like brute force algorithms and code, or like that their domain knowledge, because deep learning and data-driven AI has become so effective that how do you transfer your speciality in a domain into, for instance, healthcare, and say, how will I be valuable in developing AI within my field if it's all based on, big data and deep learning? So how do you see the trends in companies and organizations putting teams together? Is it mostly a computer science oriented approach, or do we see a shift maybe towards, especially with more explainable AI coming in demand, and maybe even regulations saying like you have to actually be able to put down why did the algorithm recommend this treatment or that treatment? Then you will need these domain expert, I think, to maybe explain. So maybe it's a very broad, open topic, but maybe you could elaborate on your views.
Yeah. No, totally. I mean, so first of all, I think there is a higher demand in having more diverse teams being put together. As you said, the traditional approach, and I've been working in many teams where you had healthcare professionals, medical doctors, and you had the IT folks. What often happens is you have very enthusiastic medical folks. They understand, they like this area, but and then you have also the technicians, let's say, the technology approach. But it's actually a bit tough to get them both together. What seems to be and then maybe it's worth noting, I have received many questions what to do with a wider portfolio of backgrounds. So there are, for example, psychologists, political experts, lawyers, very important in these situations. So I think I see more of these combined teams being created across the board. There is a big shift that happened in the last few years, whereby the first phase of this AI era here in Europe was that a lot of company CEOs and leaders went over to the Valley and got inspired and went over to Shenzhen and China and saw, hey, what are these cool startups are doing? And they created COEs and specialized AI teams in companies. And that sort of stopped in the last 1 or 2 years. The companies realized, it's not enough to just have technical experts sitting in one corner of the company, having no power, no business power in changing the organization, or having industry experts in this organization. So it's not efficient. So there's certainly what is now happening is that you have teams which have a much bigger mandate. They have a much wider group of people that you need to work with, and also articulate the value proposition. So business experts, that can really scale this approach across the company. So there's definitely, and this is such an era that is going to be changing the IT and computer science world quite in a fundamental way, I would say.
Great. Should we go back to the document?
Mm-hmm.
I can see there was a little typing going on.
Yeah. Aha, you actually wrote this here too, Caspar. Okay, so yeah, please, when you go to the document, is there, let me just do that again here. I go to presenter mode. Decision predicting like when developing food. So there's 2 or 3 points here on treatments for diabetic food ulcers. The people, the group that wrote this down, would you be happy to share a bit your thoughts or your questions around it?
Yes, it was me.
Okay.
Just it's a case I know of, and I find it interesting, especially predicting the likelihood of developing food ulcer if you already have diabetes. I mean, it's important to be able to predict, to prevent it, because it can lead to amputation. And what I find interesting about it from a machine learning perspective, because I'm coming with a computer science background, is that it's a combination of all kinds of factors that can lead to food ulcer. So you have a lot of different data that you can use to predict these kind of things.
Exactly. I mean, and it's, I guess, also, is this an area that you have been looking at, or you know something about?
No, it's not. It's just I'm coming from a computer science background. I'm currently using computer vision, deep learning, but for a completely different area in the manufacturing industry. Well, I just like the idea of applying it to the health sector instead.
Yeah. No, this is very good. And I worked in Australia in a very big project whereby patients with a chronic condition, particularly diabetes, there was actually, this is another area, multi-agent systems, right, which I mentioned before, whereby you often have quite complex care plans for patients with diabetes. They need to, for example, go to a foot doctor, podiatrist, and to check their vision, to check all sorts of things. So it becomes actually quite a complex plan that you need to follow, often far more complex than most people with a busy lifestyle or when they are older are able to really follow. So we developed an AI system, a multi-agent system, whereby every actor, including doctors, including friends, are having an assistant, an intelligent assistant that would sort of remind them where to go and what to do. Potentially, also detecting when things are going off track. And yeah, so this also included detections of potential risk states and predictions of complications. Foot ulcers would be some of them because, as the podiatrist checks the information, you can augment this, with pictures maybe and with other data and start having a better prediction of these outcomes. So yeah, it's a very big field, and sometimes it is worth also reflecting over how big the condition is, because diabetic is one of the largest problems we have in the world, right? So here in the Western world, it's going up too, but in places also like India and so on, it's just rising up hugely, right? So it's becoming increasingly important to apply this.
So when you apply these agents, are they based on smartphones, or how do you manifest these intelligent
these patients? They are agents, so there is actually a very different implementation platform. It's not Python or something, but it would be something called, it's BDI architectures. And yes, they can be on mobile phones, they can be on wearable devices, they can be on the doctor's office platform, and in tools like patient journal data, where the patient journal data is, and so on. So each of these agents had access to this data that we used, and then would essentially start not only creating a plan, but also maintaining the plan for the patients, depending on what the conditions are. Because obviously a plan is only as good as it is updated, with new information. But we published a couple of papers on this, and it also turned now into a company called Precedence Healthcare in Australia. And there's used a different version is used in practice, but the basic idea behind it is very consistent. So, and then yeah, if I may proceed here, I'm just looking at some other topics. Thanks for the explanation. Very important area. Okay, so someone had the idea of one blood sample and predicting multiple diseases in the future. Does the person are you still on the call? Do you like to elaborate a bit?
Hey, Krishna here. Just made it. I think in India, a couple of large healthcare providers are already working, but I'm not sure how far they achieve or what exactly the use case tied up. But when I started learning the AI and implementation of all these deep learning models, so I thought this would be an interesting use case, that because for each and every disease, the common test would be blood samples, urine tests, and normal X-rays, right? So more are common, like yeah, blood and urine too. So if you have a sample for one disease, like one sample of blood, so ideally the report will come specific to that report, right? So for either fasting or glucose or something. But if you compare this blood report against the all historical blood samples of the similar kind, so we can tell them not only you will get nearby this glucose or other diseases as well with the one sample. So you don't need to go multiple tests a day. So that's one of the use cases I just wanted.
Okay, now I think I might have not been the only one not hearing you fully, but it was a bit quiet. But yeah, of course, it's a powerful example. What I can mention here is there is some extremely impressive technology that's underway, which is, I mean, we know already the the Apple Watches and Fitbits and the wearables that are measuring movement, that are measuring body temperature, that are measuring heart rates and so on. So that's great, and that has been around for quite some while. What's now really cool is that there is a way of measuring what is in your blood by technologies such as wide spectrum or green spectrum light. So as you're shining it through your finger, let's say, you can actually, let's say, I'm not overselling it here, overstating it, but it can essentially detect a whole bunch of things which otherwise would be possible only through actually taking blood. So through this wide spectrum technology, you're able to detect, a whole bunch of things, and it replaces to some extent the actually taking blood and doing tests in the laboratory.
Yeah, with the light, SpO2 pulse, and those are all, it's happening with the app-based instead of pulse oximeter.
Yes, along those lines. And it becomes more and more sophisticated now. There's a Norwegian company that developed this technology too. So it's really cool. I mean, I'm looking forward to this technology where essentially I will receive an overview of the blood status. Having this, imagine, and this is what I meant earlier with, not just focusing on the legacy data, but if you have 24-hour data about your blood, about your, about your movements and everything, you have a lot of power in predicting the onset of certain conditions days, weeks before they occur, and that's of course extremely powerful.
Yeah,
I might
that's
just
another use case. The third one I mentioned, detect cardiac arrest.
Yeah.
It should be the same. Yeah, or we are having more wearable gadgets, right? So it continuously detect, and maybe it gives when there is a cardiac arrest happens. Maybe immediate a pulse impact should be given to the patient, and immediately send a signal to ambulance or nearby hospital, so that they can come pick up that patient immediately. That can be
Yeah, totally, really good. And in fact, there is a company in Denmark. It's a Danish company They don't do cardiac assessment through wearable devices, but they actually use it in emergency calls. So that's a really cool application for if you want to scan a little bit the Danish system. There's a company called Corti, Corti. And when you're making now an emergency call in Denmark or now in Sweden too, and in Seattle, more or less, you are having a human that responds, but you will have an AI in the background that completes the record of what you have been saying in the emergency call. That's one part, but it goes even further. If it can even detect, now I need to remember, it is cardiac, I think it is cardiac arrest or something to do with the cardiac rhythm. So it's worth looking up, but it can do it through breathing and other type of mechanisms just on the phone. So it's actually very powerful. Papers were published, and the authorities in some countries have accepted it as a tool and as a technology that can help dramatically in emergency calls. So very, very powerful technology. Very interesting. And now we have about 4 minutes left. What I suggest is we go back. I mean, these are really great points. We may have not gone through all of them, but it shows that you are very creative in your, in what's happening in this space. I think there is certainly a lot of possibilities. Maybe, as some of you already mentioned before, it's of course a space which is very established. So it's not that easy to go into healthcare and just lay out your ideas from a technological perspective. The way how I have been succeeding in applying AI technology in the healthcare sector is to really align with the right decision makers, making sure that you also have medical doctors, nurses, expert in the field that are with you on the journey. What I don't think works so well is if you have a purely, let's say, AI machine learning data-driven idea alone without sort of evaluating or validating it in the healthcare sector. I mean, there's many startups that start that way and realize after a year or two, or maybe hopefully earlier sometimes, that that's not the most effective way forward. But you can also reach out to me. I'm helping. I'm an advisor to startups in this field, and I have a lot of battle experience, let's say, so happy to share more thoughts on that too. And there's also more and more investors in this field which are very interested in this area of healthcare, medicine, pharmaceutical, and AI. It becomes an increasingly bigger topic. Yeah, happy to advise further.
Christian, I skipped a question earlier from Henrik. And I thought that was an interesting question because it was about healthcare staff. What if they're interested in getting into machine learning and AI, but have a hard time getting into it? What would your advice be?
And what background would they have? What was this question?
Medical staff, so an MD, for example, a doctor.
Okay. Yeah, that's good question. I have the experience. I can say first up, it's very good. I have good experience. I know many medical doctors and nurses and health professionals that have worked their way from the medical field into the AI field, and they are really effective. I mean, when I see medical doctors starting to work with data or starting to apply AI algorithms, good stuff comes out of it. So I could point to many examples, very, very powerful. So encourage them very much. Perhaps it's also worth noting that the field of medicine is a bit like psychology. And because I studied both, I sort of know that the approach to this is quite different, right? Whereas in medicine, many books, a lot of anatomy, a lot of knowledge about drugs and so on and so on. In AI it's more mathematical, more computational, more algorithms. So that's something worth keeping in the back of your mind. That shouldn't hinder you. But if you want to warm up and really start applying, there's many toolkits that you can use online. There's things where you can essentially apply already data in this field. If you want to do a specific education, I could probably point you offline to a few a few areas where you have this AI machine learning healthcare field. You can learn about it. You can get courses in it that allow you to have an entrance into this field. It probably depends a little bit what you want to end up being. Do you want to be, do you want to apply it and implement it? Do you want to become a data scientist, or do you want to become an AI expert? Do you want to do it for research purposes? What's the reason behind it will also help me to give you some advice, because that would certainly be helping here too. But please, yeah, reach out to me, and you can certainly also reach out to me on LinkedIn and on Twitter for sure. I'm happy to engage.
Perfect. So here's a last chance to ask a question, and then we're gonna close the session for today.
Can I ask one last question?
Yes, you can, Kasper.
I'm sure. I don't know if it's so I think the diabetes case that Troels brought up is very interesting. It's very obviously very relevant, and it's also very multifaceted, because it's individual human behavior, it's individual blood glucose metabolism. So yes, you can train general models, but it also needs to be adapted to the unique person to be effective. So how do you see the personalization of AI algorithms in terms so one is to do these big, we can screen for cancer and detect using MRI scans or whatnot. But the other one is actually detecting algorithms that will adapt to us and as individuals. And we're seeing things like digital twins and other kind of where we are applying it into models that we can trust and that will kind of align with our personal development during a diabetes, for instance. Do you see any trends in that, and what kind of methods do you see being the solutions to that?
Yeah. No, totally. I think this is mentioned when I mentioned before, personalized healthcare and precision medicine. It goes in. This is this huge field that's emerging, and I'm just trying to think of a colleague in the US. He's very prevalent. I will share it in the chat maybe later, but. Certainly, this whole idea, and this is possibly one of the greatest applications, is that you have the opportunity to personalize the care. And then once you crack that, once you have the methods in order to make your care plans, for example, in diabetes, personalized, you can scale it. I mean, these are sort of the two powerful things, mass customization, if you want to call it, which, as maybe some of you in this call already know, is certainly applied in many other domains, right? Whether it's your music recommendation list on Spotify or whatever it might be. So the same principles would apply here. I think and also the truth spoken, I don't know if you have GPs here, general practitioners on the call, but of course you have these very highly abstract clinical trials for medication, let's say, or for certain treatments, which divide the groups in clinical trials and control and test groups. And then you apply this to your patients. And every patient that comes in actually has a very different background, exactly as you said, Kasper, right? You don't have the vanilla patient that you before had in the clinical trial. So there is already today essentially a very personalized adaptations by the medical professionals, which is not technically speaking entirely scientifically and data based, right? It is really adapted. It's like, okay, well, you can't tolerate the medication, we go to another one. But that sort of approach and this personalization is extremely it's just worked on more and more, and it's certainly this combination between your DNA and your microbiome versus the medication and the drugs that are applied. There is a lot more research to essentially look at how you're reacting to certain molecules and to certain drug components, and that can guide the variety of drugs. I don't think we jump straight to a healthcare system where everything is fully and 100% personalized. Let's say one-on-one type thing, but I think it will become phenotyped, and you have groups which you are closer to, and then it will be helpful to use this personalization. So I think it will come in steps.
Thank you.
Great. I think that was a beautiful ending to a very nice talk. I have a feeling that this could have lasted much longer, but hopefully in the not too distant future, Christian will be able to welcome you to the department.
Yeah, would love to come. Totally. Yes, I look forward
Great.
to that.
Yes. So, Christian, thank you so much. Thank you. If you would have been here in real life, I'm sure you would have received a massive round of applause. Unfortunately, that doesn't really work on Teams. But nevertheless, we really appreciate you taking the time to contribute. So a big thank you for that. And also thank you to the rest of you for attending. You will receive an email tomorrow with the recording in case you missed parts of the session. So that's it for now. Keep an eye on our upcoming events, and hope to see you all soon, and have a good evening.
Thanks so
Thank
much.
you so much, Chris.
Thank you.